Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the maximum non-expansion work per mole of C3H8 that may be obtained from a fuel cell in which the chemical reaction is the combustion of propane under standard conditions. So the first thing you have to note is calculate the maximum non-expansion work per mole. You're asked to find the work per mole of C3H8, which is propane gas, that may be obtained from a fuel cell in which the chemical reaction is the combustion of propane under standard conditions. So we're told to calculate the maximum expansion work. For any of you who don't know, this is just a trick question. Indirectly, what they're asking you is for you to determine the standard Gibbs energy of reaction is the same thing as the maximum, okay, non-expansion work. So there isn't one particular formula to necessarily determine this in terms of non-expansion work, right? It is just simply them using another synonym for this maximum non-expansion work, which is simply the standard Gibbs energy of reaction. That is basically what you're trying to tell us to solve. If you look at your physical chemistry actions textbook, you're going to see that this information, maximum non-expansion work per mole, okay, is the same thing as calculating the standard Gibbs energy of reaction. So that is it. Now, I wanted to also say that they said there is a chemical reaction, which is the combustion of propane under standard conditions. Well, important again for you to note that this is a combustion reaction. So that's going to be C3H8. Okay, it's going to be reacted with oxygen to form the real combustion reaction. Anytime you're dealing with combustion of organic compounds, is just note that that organic compound reacting with oxygen is always going to give you carbon dioxide and water. So that is it. So we have C3H gas, we have oxygen gas, we have carbon dioxide gas, and we're going to end up with water as a liquid. So that is basically what we're doing here. Now, of course, the next thing we do, like we do in every chemistry question, is to simply balance the chemical equation. So you have a 3 here to balance the carbons. Then you have H8. Well, you have 8 hydrogens. You have 2 here. You're just going to put a 4 here to balance the hydrogens. So you have the carbon and hydrogen balance. Now you just have to deal with the oxygen. You've got 6 oxygens here. You've got 4 oxygens here. So you just put a 5 here to balance the 10 oxygens on the right. So this is the balanced chemical equation, which is just C3H8 gas plus 5O2 gas would give you 3 molecules of carbon dioxide gas and 4 molecules of hydrogen gas. So now we've written this down. The next thing we have to simply do is to find the standard Gibbs energy of reaction for this reaction we just wrote based on the chemical equation. So that's it. Now, for any of you who don't know, the standard Gibbs energy of reaction, okay, the formula for it is just simply the summation, okay, of the Gibbs energy, okay, the change in Gibbs energy or formation or whatever you want to call it. Let me just draw it here. So the Gibbs energy of formation for the products, okay, minus the summation of the Gibbs energy of formation for the reactants, where the value for V is basically the coefficient for products, okay, here, and the value for V on the right is the coefficient for reactants. So that is it. So next, what we're going to do is we're going to apply this formula to this particular chemical equation. So you have the formation, the standard formation for the product side. So we're going to deal with the first product, which is just 3CO2 gas, okay, plus the formation, the Gibbs energy of the Gibbs energy of formation of the second product, which is just 4H2O, according to this reaction, okay, minus, okay, let's scroll up, minus the Gibbs energy of formation for the first reactant. So the Gibbs energy of formation for the first reactant, which is simply C3H8. So that would be C3H8 gas, of course, plus the Gibbs energy of formation for the second reactant, which is just simply 5O2 gas. So that would be 5O2 gas. So this is basically our work. Now, I wanted to quickly also mention this to you guys. This is the first organization. We have to reorganize this again a second time. And the way this is just for you to bring out the coefficient that isn't one. So if there's a coefficient in front of any of the compounds, you have to bring it out, except if that coefficient is one. So what I'm saying is that you say three times the Gibbs energy of formation for CO2, okay, for CO2 gas. That's how you do it. Plus four times the Gibbs energy of formation for H2O liquid. Okay, that's what we're doing here because we want our work to be very neat and I want it to be easy for you guys to understand. Here, the coefficient is one, so we're just going to rewrite that. So it gives energy of formation for propane gas, so C3H8 gas, plus five times the Gibbs energy of formation for this last reactant. So that would be just O2 gas. So that's it. The next thing you, of course, do is for you to substitute. But before we go further, I wanted to tell you guys that I'm using the Physical Chemistry Atkins 11 edition textbook. And in the textbook, we have all of the Gibbs energy of formation values in the resource section of this textbook. So I am just going to be using the values from my textbook. But because I want it to be easy for you guys to follow along, I am just going to write out all of the Gibbs energy of formation for all of these molecules, the four molecules we have. So now I'm done writing the values. I advise you to pause this video and actually just write out the values because I have my notes with me and I'm not going to be going back and forth, back and forth, back and forth to this page to be able to continue working with this problem. So I'm just gonna skip doing that. Okay, like I'm not gonna be doing that the entire problem. So just make sure you pause this video and answer it. So we have this right here. So you change in Gibbs standard Gibbs energy would just simply be three times the Gibbs energy of formation of CO2. We know that to be negative 394.36 kilojoule per mole. Okay, plus four times the standard Gibbs energy of formation for H2O. So that would be four times standard Gibbs energy of H2O. That would be four times negative 237.13 kilojoule per mole, minus the standard Gibbs energy of formation for C3H8 will be negative 23.49 kilojoule per mole, okay, plus the standard five times the standard Gibbs energy of formation for O2 gas would be five times 0 kilojoule per mole. So yeah, now I hope you guys have written it all out. So you have the standard Gibbs energy of reaction to be three times negative 394.36 kilojoule per mole is same thing as negative 1183.08 kilojoule per mole. Okay, that's one, plus four times negative 237.13 kilojoule per mole. That will be negative 948.52 kilojoule per mole. Okay, minus is just simply plus 23.49 kilojoule per mole. And then plus five times zero is just simply zero. So just say plus one large zero. So the change in standard Gibbs energy of reaction will be negative okay, negative 1183.08 kilojoule per mole minus 948.52 kilojoule per mole plus 23.49 kilojoule per mole. So you just simply input all of this information in your calculator to get the standard Gibbs energy of reaction to be negative 2108.11 kilojoule per mole as the answer to this question. So this is basically the answer to the question. Let's first of all go back to our question to make sure that we put in the proper number of decimal places because we're always supposed to put in the proper number of decimal places in chemistry. So we look at the decimal places of what we used. We have two decimal places here, two decimal places here, two decimal places here. Then our answer is actually in two decimal places. So this is correct. I want to quickly mention something so that there isn't any confusion. I have noticed that in some questions, some answer or some solutions on the internet, they use plus 2108.11 kilojoule per mole instead of negative. So I think this point is, and I explained this in my other video where I had the first version of this question where we did the combustion of methane gas, and then this one we're doing the combustion of propane gas. I explained that it's possible that maybe some of you are taking, you're not taking this question as a chemistry major like I did. You're not taking this class, this course, physical chemistry, as a chemistry major, but you're taking it as something else. So what I'm trying to do for mine is negative 2108.11. I am doing this question based on the fact that I know the fuel cell does work, right? Meaning it ends up having negative, having lesser energy, while the people who may be using plus 2108.11 may actually be trying to say that this amount was of work was done. So they don't actually put a negative in front. While I am also saying that even though this amount of work was done, it was done by the system. So the system has lesser amount of energy. That's the reason why I'm putting negative. Some other people would put an absolute value and put a positive there to just tell you that this is the value of work done, while I'm giving you the raw data that not only was work done, there was a deficit because the system did the work. So I think that's the difference. If you don't understand what I'm saying, just rewatch what I've said. But if you want further explanation, please do your research or ask your professor to explain the reason why someone else might put absolute value on this value and end up having positive 2108.11, and why somebody else might decide to leave your answer in negative 2108.11. I'm choosing to leave my answer in the raw value. So if you have any questions, please put in the comment section. If you have any concerns and suggestions for what you'd like me to do next, also leave in the comment section. I am an online tutor that helps students in middle school, high school, and college level to succeed and be the best version of themselves in academia. So if you're in need of tutoring for your STEM related courses, make sure you email me at shohabitutoring@gmail.com. I also help students who are struggling in college to be able to find their path and to have a better, greater student academic life. So yeah, if you have any questions or in need of any of my services, make sure you email me at shohabitutoring@gmail.com for and I'll try my possible to give you the help that you need. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.